do it. It's go time.
Welcome to Go Time, your source for wide-ranging discussions from all around the Go community. Find us on the web at gotime.fm, on the Fediverse at gotime, at changelog.social, and on X at GoTimeFM. Big thanks to our partners at Fly.io, the home of changelog.com. Fly transforms containers into micro VMs that run on their hardware in 30-plus regions on 6 continents, so you can launch your app near your users. Learn more at Fly.io. Okay, here we go.
Hello, everyone, and welcome to Go Time. Today, I am joined by fellow co-host Chris Brando. Chris, how are you doing?
I'm doing well. Happy New Year, since this is our first episode of the year.
I guess this is our first episode of the year. I completely zoned on that. I guess we let the ball drop and didn't have one out last week.
It happens.
All right. We're also joined today by Matt Boyle. Matt, how are you?
Yeah, good, thank you. Happy New Year. It feels weird to be saying that at this point in January. I thought I'd done all my Happy New Year's, but Happy New Year's, folks.
All right. So today, Matt is joining us to talk about Kafka. So I guess we could just start off right with Matt. Would you like to tell us about your experience with Kafka so people know why you are authorized to talk about it?
Authorized is a strong word, but I've been interacting with Kafka in some capacity every day for the last 3 or 4 years. I'm an engineering manager at Cloudflare, and part of my team's responsibility is to provide tooling to make it easier for other teams to interact with Kafka and provide sensible defaults around various different configurations and how you work with it, etc. And nearly all of that's written in Go.
I also recall that you've written a couple blog posts about Kafka, haven't you?
Yeah, I seem to have accidentally ended up in a niche where I write about Kafka quite a lot. So I wrote one for the Cloudflare blog, which was basically just telling the history of Kafka usage at Cloudflare. I've also wrote a few bits and pieces and done a couple of conference talks around kind of dealing with failure with Kafka too. Like when things go wrong, like how you can think about it, how you can reason about it, and how you can build patterns to help it self-heal, if you will, make your applications carry on running even when things aren't behaving how you'd like them to.
That's always good to know because, as we all know, computers don't always work the way we want them to. Chris had lots of fun with that today.
Yeah. Computers rarely work the way we want them to.
Okay, so I wanted to start off thinking about this more from a beginner perspective of kind of talking about what Kafka is and leading into like why somebody might start introducing it to their tech stack. And then we can dive into more complex subjects as we get there. But rather than just jumping right into the deep stuff, I wanted to talk about just what is Kafka at like a sort of beginner level.
Yeah, for sure. So one thing I would recommend as well is after this episode, go and listen to the event-driven architecture episode of Go Time from, I think it was last week, because they actually dive into a lot of the reasons you might use Kafka in a lot of detail and even talk about Kafka a tiny bit at the end of the episode. So it complements this episode really nicely. I was listening to it in preparation of this and just nodding my head all the way through it. But Kafka's essentially it can be used for a couple of things, but effectively it's a distributed data source. So it's kind of optimized for ingesting, processing, and streaming data. And by streaming it, I mean, it could be coming from thousands of data sources at once and then kind of landing and going through Kafka before, either going to a different system or maybe even sitting there. One really wild reading of Kafka is it could be used as a database. It's a write-append log. So there's some really interesting use cases that come because of that. Kafka can process data sequentially or incrementally, kind of depends what you want to use it for. But it mostly gets used for kind of data pipelines, moving stuff from one place to another, or how we use it at Cloudflare often is using it as a message broker, where it kind of sits in the middle of 2 applications and kind of can help you, build an event-driven architecture, and means that you can integrate with other systems without knowing too much of the details about how those systems are going to communicate. You just kind of emit messages and events of things that are happening around your company, and other things that are interested can listen and pick those up. And so data streaming and sort of that mediator between lots of different applications are the really popular use cases of Kafka typically.
So when you're talking about these circumstances where you're emitting messages and not really understanding, you don't have to know too much about the other services. What circumstances kind of lead to a company needing to do that? Because a lot of people, when they get started, they build a monolithic application that, everything's sort of self-contained in one thing. So how do you get to the point where something like this is necessary?
Yeah, so it kind of gets down into the microservices conversation a little bit. And there's tons of people and there's tons of great writing about why you should never use microservices. I'm a big fan of them. I think they help you kind of manage failure and kind of keep it isolated. So once you start to get to a certain scale where you've got like huge feature sets, you've got huge products, and maybe you have a lot of diversity in your products, where it can kind of make sense for them to scale or fail independently, it might be a good time to start thinking about whether an event-driven architecture could be beneficial to you. And you may choose to use Kafka as sort of the mediator for some of that conversation, if you will. So Cloudflare is a great example. At Cloudflare, we have hundreds of products, and we have a very clear separation of what some of those products do. We have things like CDN, which obviously can help serve up assets that are commonly used from the edge. But we also do things like alerting, which we mainly kind of do on processing, things that happen after the fact. Those two things are not coupled at all, and they can survive and offer like value to our customers independently. So having them as separate services makes a ton of sense. And the service that serves our CDN will shoot messages out that will get read by other services at Cloudflare, but they will be completely separate.
So when you're talking about like messaging brokers like Kafka and using it that way, do you happen to know like sort of what are companies typically doing before they get to that point where they add a messaging broker of some sort or use a messaging service of some sort in the middle? And why does that technique or whatever they're using tend to not start to fail essentially?
Yeah, it's a great question. And I think, I'll start by saying that I think you can get an awful long way without using Kafka. And it might be that you never need it. It does come with a bunch of complexity, which we can dig into in a little bit. But, it's definitely not given that every company will end up needing or wanting something like Kafka. I think you described the initial situation that most folks start from, which is, the monolithic application or maybe a couple of microservices that talk to each other synchronously. And then maybe you'll start to think about other use cases. So maybe you started with a couple of services that were talking to each other directly, but you wanted to build a data warehouse. So you wanted to have like data pipelines of processes that happen after, let's say after a user is created. The user is created, and instead of just creating an account, you want to kind of store that somewhere else. Or maybe it kicks off some marketing campaign, or maybe you have to report it to some government body because of, I don't know, maybe you're working in banking, something like that. There might be like 5, 6, 7, 8, 9 things that happen because a user was created. And, for a while you can kind of just write more code and you have this stack of calls that you're going to make. But if one of those fails, what happens to the 4 that happened before it? And what happens to the 4 of it? The 4 things that were meant to happen after it. And when you start to get into these situations where you have like a bunch of things that are kind of independent, but at the moment they're being treated as a stack, it could be a good opportunity to start thinking about, well, which of these things need to happen in what I call like the user flow? Which of these things do I need to wait for the user? Does the user need to wait for to complete before I can say, I can give them back a 200 response code? And for most of it, it's just that we've accepted your application or that we've created a user. That's the only thing you need to know about at this time, right? And so making you wait until we've submitted something to our data team or that we've submitted something to a third party that is part of our internal processes, but not part of actually creating a user account, it's probably a good time to start thinking about splitting some of those things out. And so as part of that conversation, you might look at a few different message brokers. And there's tons of options out there. You can do stuff in code. I used to write, I don't know if I'm allowed to say this in GoTime, but I used to write PHP a long time ago. And Laravel has some really nice stuff built into it that allows you to do sort of internal message communication, even within the application itself. You can build almost like a message bus within the application. And that can be a really great place to start. And if you interface that well, it's very easy to swap that out to be Redis instead. Redis is very, very easy to spin up as a message, maybe not message broker is the wrong term, but it can do like publish subscriber stuff where you can write things to Redis and other things can listen and they can start taking actions on that. So there's these very small steps you can take to move away from this very monolithic, everything happens at once thing to, okay, now we've got a few things happening off of a single event happening. And as you start to uncover more and more complexity, you might start to feel that the choice you made, the Laravel internal message broker using Redis, doesn't quite match your resilience use case or your latency use case anymore. And at those points, you might need to look around again and start thinking about, maybe I need to look at RabbitMQ, maybe I need to look at Kafka, maybe I need to look at Pulsar, which is another one that's getting popular. I haven't used it too much yet, but Pulsar seems to be another one that's sort of raising in popularity.
It seems like you probably want to start using something like Kafka or really any of these types of message brokers or things like that once you have a decoupling between like the teams and the dependencies. So it's like you might be producing data that somebody who you don't even interact with wants to consume. And so you want to set something up like this so that it's possible for them to do without you having to be like, oh, I actually have to like call your service or hand you this data directly. It's like you can just go get it from over there. And it seems like you probably want something like Kafka when you scale up to the level where you have a lot of that happening in your organization, where it's like, if it's small, you probably do that with just like a shared database or with Redis, as you mentioned, or with maybe something internal to your monolith. But as you kind of scale up, those options become untenable, especially when you want to deal with data migrations and things like that.
Yeah, that's a great way to think about it. And I think you hit on a really good point there, which is one of the huge benefits. And this happens all the time at Cloudflare. Like we emit domain events, account created, things like that is the obvious and easy one. And there'll be teams listening to those so you might own the service that emits the account created event. And there might be teams consuming it that you actually have never interacted with because you've emitted something, it has a contract, they read it and they do whatever they need to do given that information. And they've built a powerful system off of an event that you emitted and never had to communicate with your team. And that's incredibly powerful as you start to scale your engineering team.
I think the episode you had mentioned that was on event-driven architecture, that was, I think, 1 or 2 weeks ago, whatever it was. The one example they had on that one that was, I thought, really good is that webhooks are kind of a way of thinking about this, where a service can emit events of some sort that your application can consume, and they don't really need to know what your application does with it. So I think that's, if I was talking to a beginner who was like, what might I use it for? I think I'd point them to like, if you're using an API that has webhooks and you're using those, think about in your system, if you get to a point where that type of setup could be useful, where you want to be able to emit those events and people can do whatever they want with them, whatever type of information that is, that makes it really handy at that point. And I think it's easier to understand at that point because a lot of people end up using webhooks before they use Kafka. At least I think in my experience, that's what ends up happening.
I think that's true because I think there's some really great products out there now that have made webhooks really accessible. I always remember the first interaction I had with webhooks was GitHub and being able to they had a really great API where you could listen to commit messages being made and stuff like that. And then tools like, I'll probably pronounce this horribly, but Zapier has made it so it's like kind of like webhooks as a service. You can just click things together and build really powerful workflows without even having to really understand how webhooks work. So they've kind of almost brought this event-driven model front and center, even if people don't realize that's what they're interacting with.
This is a changelog news break. Vanna.ai is a Python RAG framework for accurate text to SQL generation. It lets you chat with any relational database by accurately generating SQL queries trained via RAG, which stands for Retrieval Augmented Generation, to use with any LLM that you want. You load up your data definitions, your documentation, and any raw SQL queries you have laying around into Vanna, and then you're off to the races. Vanna boasts high accuracy on complex datasets, excellent security and privacy because your database contents are never sent to the LLM or a vector DB. It boasts the ability to self-learn by choosing to auto-train on successful queries, and a choose-your-own front-end approach with front ends provided for Jupyter Notebook, Streamlit, Flask, and Slack. You just heard one of our 5 top stories from Monday's Changelog News. Subscribe to the podcast to get all of the week's top stories and pop your email address in at changelog.com/news to also receive our free companion email with even more developer news worth your attention. Once again, that's changelog.com/news.
So let's say we get to the point where we're ready to try using Kafka. Are there any, I guess, like barriers to entry or things that people need to worry about when they're trying to try it out?
Yeah, that's a good question. I think, to be honest, if it depends why people wanted to use Kafka, but I would a lot of times probably try and turn people away from it, honestly. Unless they've kind of got a really good sort of vision in their head about why they're using it, or it's very clear their company's going to get to, a scale where it makes sense. It does come with a lot of complexity that can be avoided by using some other tools. I think this is trending downwards these days as there's more and more companies and managed services available that are making it even easier to get started with Kafka than ever before. I tweeted about one recently. I've been playing around with Memphis.dev, which is really cool. It's kind of providing abstractions over Kafka that makes it kind of possible to get started if you don't have a bunch of experience or expertise. But kind of to answer the question directly around sort of what those barriers to entry are, is there's some language and things you need to learn before you can even start using Kafka. So, for example, there's a concept of a topic where you have to emit messages, and then topics are split down further into partitions. And there's some real gotchas, like ordering is only guaranteed within a partition, not within a topic. And so you could start using Kafka, and if you didn't know that and you made a mistake, you could cause chaos within your application, right? So there's kind of this learning curve on both the person emitting the messages side, the person consuming the message side, and also actually running the infrastructure is pretty complicated too. At Cloudflare, we run it ourselves. I wouldn't recommend doing that unless you've got like a pretty sizable engineering team. And for most people, the sort of managed services available are probably the way to go. And in some cases, using Kafka is going to be a complete re-architecture of your application. You know, we've talked a little bit about the monolith to the event-driven architecture sort of style and maybe data streaming, stuff like that. It's not something you want to do unless you've identified that you need to do it, because I think moving to event-driven architectures in some environments is like a sexy project. It's a cool thing to do, but they are incredibly difficult to do and to do well. And in a lot of cases, you end up with the worst of both worlds. You have this half event-driven architecture and this half monolithic thing. And I'm seeing everyone smiling because I think we've all worked on those systems. And you need the time to commit to do those things well.
I think there's also a level of you need to have good communication systems within your company. Like, right, if you have to directly integrate to get data from somebody and they have to like call your service or hand you some data, then there's like a sit down meeting you have and there's like a point of synchronization that occurs. But if you just have streams and feeds of data that you're pulling off of, from Kafka, a change you make as a team might have very wide effects on other people in the organization, like deprecating a field or deprecating an event you emit or changing how you emit an event. And if you don't already have that communication structure set up to properly kind of broadcast these things out to everybody, you can get yourself into a lot of trouble. I've definitely experienced that in the past. And you have to be prepared for what life with a append-only log essentially looks like, where it's like your data migrations don't look the same. Rewriting history is not really something that you can do. So if you want to get more than just like the simple message bus and you want to actually be able to use the history of things you have in Kafka, you have to actually start thinking about your data in different ways as well. And your organization and your engineers have to be prepared for that kind of reality.
That's a really great thing to call out as well, because it's something I think I take for granted now. But one thing that Kafka doesn't give you out of the box is like strong schemas on your events. So the same way when you build an API, you build an API contract, and we all kind of know that you shouldn't rename all the fields and delete fields and stuff because that can be consequential. And there's patterns for doing that. Maybe you'll version the endpoint, or, if you use gRPC, like you do some other things. Out of the box, Kafka doesn't do any of that for you. So you need to start thinking about how you do want to manage the schema of your messages. And there's a few different ways to do this. There's a really popular tool called Apache Avro, which is like a way to do some schema stuff. But at Cloudflare, we use Protobuf. So all of our message schemas, we have a central repository that's got a bunch of checks on it for breaking change detection and stuff like that. For exactly the reason that Kris mentioned there is if someone tries to remove a field on a schema, that could cause havoc if we don't handle it well. So we just straight up just reject those changes. If you try and make a pull request and you're going to make a breaking change to a schema, we just don't allow that to happen. A slightly controversial decision we made that I think has been a good one for Kafka adoption is we made it so you can only emit one event type to one topic. So again, Kafka doesn't stop you from doing this. You could have a user created event, you could have account created event, you could have account top event. They could all go to the same topic, and a service may read all of them and care about all of them. What we did is we said user created events can only go to a topic called user created event. And then I think we version them as well underscore v1 underscore v2. If you try and emit any other type of message to that topic, we'll reject it. And that was, again, for some of the reasons that Kris mentioned there, is people can expect what pops out of the other side of every topic. And that makes it very, very easy for things to be predictable. And I must say, we haven't had any real issues with schema or sort of changes to messages since we made sort of that enforcement. So I think that was a really useful and powerful thing we did to help drive adoption and to stop some of these fuck guns that can happen if you don't do these things.
Another one I'd bring up as well is that the security model around Kafka is, I guess, a bit different than if you're doing direct communication between services, because it's like there's something in this topic. Where did that thing come from? And you have to lock down who can publish to that topic to specific services, or have some sort of authentication on the data itself, which is like a sort of complex thing that you need to think about that I think a lot of people just like, it doesn't pop into their head when they think about this type of architecture. Like, oh, all of these events, how nice. But it's like, you don't have that provenance of where did this event come from? All you know is that it got in the queue and it's in the queue, or it's got in the lock, it's in the lock, and you can process it. But that isn't a potential attack point for people that get into your network. And it also makes Kafka a very nice target for people that want to do nefarious things to your products, your infrastructure, all of that, which means you have to be especially careful around permissioning and how you kind of integrate things with Kafka. Even just taking over one rogue application, if kind of anything can write to any topic, that could cause lots of problems. There's a lot of those types of security vulnerabilities that you need to keep in mind when you start using not even just this technology, not Kafka specifically, but any type of technology like this.
Yeah, it's a really good point, because also message brokers and Kafka are natural amplification vectors, aren't they? If I emit one message, 9 services might do something, or 10 services, or 15 services. So it's if you do want to cause chaos, like emitting one message to a topic might lead to 15 services taking action. It's a natural amplification that happens in the system. So, getting that permissioning and that security model right is super important, because even teams that don't mean to, say someone emits a message in good faith or starts changing things or emitting a bunch of test messages or something like that, it could cause chaos, and they didn't mean to do that. They were maybe just playing around. So having good protections around these things, basically all the things you think about when you think about building an API, they all apply here, just in a slightly different way that you need to think about up front. So, we've just talked about versioning. We've talked about sort of almost like having rate limits, right, on your cluster, and sort of having permissioning to make sure you know who's talking to you and that you trust them is a really important thing to think about, that often can be things you don't think about until the end, but they really do need to be thought about up front here.
Yeah, I think that's like probably a good point of suggestion as well. Is like, if you're struggling with using APIs right now and getting the API contracts and the design of APIs and security model around APIs right, you probably shouldn't move to one of these architectures, because you have to absolutely get it right at the front end. It's much harder to fix these things later on after you've already like deployed a system and things are working. I have tried. It is it's like very frustrating to try and fix things afterward. So if you're because I think sometimes people run to these solutions as like, oh, everything's such a mess with our APIs, we just need something better. And then someone will come in and be like, event-driven architecture or message brokers, that will solve all of our problems. And it's like, no, that will most likely make your problems even worse. So if you're having struggles with things like APIs, like the fundamentals are what's important. Like, make sure your schemas are good. Make sure you have that communication system set up. Make sure you have thought about security and you do threat modeling and all of that sort of stuff before you shift into this new world.
I think another part of that makes it challenging is that, like, I'm thinking, like, if somebody wants to learn web development and they go learn Ruby on Rails, there's a kind of clear set way of organizing code and like connecting to a database. Like, there's a lot of standardized ways to do things that help you. If you follow all these rules, your application should be relatively secure. But as you get into like more complex technologies like Kafka and event-driven architecture, it's almost like there isn't a single standard way of doing stuff. Every company sort of figured out the way that works well for them, because when you start to get to that scale, I feel like it's a lot more of it depends on what suits their needs and their use case. So it's a lot harder to teach somebody, here are the ways you do it securely and correctly, because there's not one set way of doing it. And I think that makes it really challenging, because you can't just clone what somebody else is doing and saying like, oh, Cloudflare does this, so it's got to be secure, because that setup might not work for their company.
Yeah, I think you're 100% right on that. And I think the other piece is there is a barrier to entry to learning this stuff. Like, I think it's very easy. There's tons of websites and tools and courses around, how to build a basic API, or even to do some slightly more advanced things. But there's very few sort of end-to-end courses on how to build an event-driven architecture from scratch, and how to use Kafka from scratch in a meaningful way beyond just connecting to it and publishing hello world and reading off the other side. And there's a reason for that. And it's to your point, John, like there isn't a right answer for a lot of these things. There's good patterns and good practices that you could teach, but it would be incredibly hard to kind of get that to a place where it was consumable without assuming a bunch of prerequisite knowledge of the person learning. So I think there's definitely an opportunity there for like a really good course to exist to teach people these things. But I think one thing that we're very fortunate is as time goes on, is the barrier to entry for these things is getting lower and lower all the time. I think I already mentioned Memphis.dev, and there's also Encore.dev. I think you've had them on GoTime before. And they allow you to create sort of like serverless, event-driven architectures very, very quickly and easily. And you can get started without like paying anything. So I always encourage people to go and poke around on those and build something. Just see how it all works and how it clicks together. And it's one of the few times when as a learner, there's kind of two schools of thought, isn't there? Like if you're trying to build a project that's useful to you, like you absolutely should not overcomplicate it. Like keep it simple. Make sure you ship something. Shipping's really valuable and it's a skill to learn. Once you've got a few projects under your belt, and if you are learning for the sake of learning, you go ahead and make your project incredibly complicated for no reason. Build a crazy event-driven architecture that gets deployed to Kubernetes just to see how it all clicks together and how it works. And there's so many ways you can do that for free or very, very cheap these days that it's a really great time to start trying to play around in this space. Whereas even 4, 5, 6 years ago when I was learning this stuff, you had to sign up to AWS and you had to put your credit card details in, and maybe you had to spend $50 to learn it, and that's just not accessible to everybody, right? So it is getting better.
I think that's an area too where it's like we as an industry have really encouraged people like to get started fast, and here's all the easy on ramps. But I think we do a bad job at reinforcing that you do have to go back and relearn or learn all of those underlying things. So if you do start with something that does package everything together, like it sounds like what Encore does or what Memphis.dev does or any of these other things, where it's like, hey, it gives you a nice little package thing, you still need to go back and learn all of the stuff that they're doing for you, because if you don't and their product shifts, then you're kind of screwed if they shift in a way that doesn't meet what you need. I've run into this a whole bunch of times where people like want to use some technology that is popular. Protocol buffers are a great example of this, without really understanding the complexities of actually managing them and pairing them with things like microservices. Like I literally had a job where like we had this nightmare situation, this nightmare confluence of Go modules and protocol buffers and like dozens of repos, and it just never fit together quite well. And even though each of those decisions individually made a lot of sense, when you put them together, it just didn't fit well. And a lot of that was because, people had figured out that these technologies were good and they were important and they would create a solution for us, but they hadn't actually learned all of the intricacies of how they work under the hood and the mechanics and the communication I was talking about earlier. And that just kind of led to disaster and led to, we might need to get rid of this whole platform and try rebuilding it again. So as nice as it feels to get started really quickly with these things, it's super important to go back and learn the underlying things so you can actually understand how all of it's working.
I think there's a lot to be said about that mindset of it's okay to want to learn overall how something works very quickly. And like when you're taking however you're learning, I think it's good to want to sort of get an overall picture of how everything works, so that later when you go back through and learn details, you sort of understand how everything interacts with each other, and then those details make a lot more sense. But I agree that if you just learn the overall picture and then don't ever understand the details, that all of a sudden you have that problem of you're kind of, like you said, locked into something. And I think you came from Ruby on Rails too, Kris. And I think that was something that happened a lot with people there, was that they'd kind of learn roughly how Ruby on Rails worked, but they wouldn't really understand a lot of the behind the scenes things. And then the minute you needed to do something slightly custom, it was a weird situation where some people understood it, but it was also fighting with a framework to make it happen. And I think that's why a lot of people liked moving to Go, is that I felt like you got a lot more control over that stuff. But the downside was you really had to understand how all of that stuff sort of interacted with one another. And I don't think it's any different when you get to like more complex scenarios, like using Encore or Kafka or anything else. You kind of have to have a rough idea of how everything works, I guess, like you said, at the overall level, and make sure you understand the details that you need to know.
Yeah. I actually came from the wonderful worlds of PHP and Drupal.
Oh.
But it was like a similar thing where it's like Drupal is this weird piece of technology that can do like anything that you want it to do. But I remember the feeling of when I did leave that world and was like excited about Go, it was a lot of just like, how do you even build like a very simple web application with Go? It's like, all of these things that I'm so used to having are just not here, and I have to go learn all of those fundamental things. Like, this is how a templating engine works, and this is how an HTTP server works, this is how a Muxer works, and this is how, all of these individual things kind of assemble together into, what I was used to using, which I think is a thing that happens with a lot of people. And I'll also say that, like, I think it's easy in our minds when you're learning one thing to be like, I'll just learn this thing quickly and then I'll come back around and learn the underlying stuff. But there's always something new to learn. There's always something new that you're going to want to add. So if in your mind you don't know, like you can't say when that you're actually going to go back and learn the fundamentals, you should probably take the hard road from the beginning, because it's very difficult to make the time to go back and learn if you're the type of person that's just going to keep going and just keep learning all of the surface level stuff, because it feels like you're learning a lot. It feels like you're doing a lot, but you're not. It's like that kind of empty calorie sort of thing where it's like, oh, I know how these technologies work. And then you actually have someone ask you questions about them and you're like, oh, I have no idea how these technologies work. You hit a problem and you're like, oh, look at this giant trail of things that I now have to figure out how to actually fix. And that's a situation that I've personally wound up in a few too many times for my own liking, but I've seen many organizations and companies wind up in, of just like, how did we even get here? It's like, oh, no one stopped to really push back and say, no, we actually have to learn how everything works. And it's much more painful to do that later than it is to do that right now. Just say, hey guys, we got to slow down just a little bit, just to simplify our architecture, just to learn how these technologies work so we don't get into that bad situation.
It's tangential, but there's a really popular book that I'm sure you all have heard of called Learn Kubernetes the Hard Way, that Kelsey Hightower wrote. And it's the perfect kind of framing for exactly what you're describing, Chris. Like, it's a book that teaches you a bunch, but you can be practical as you go through it. Like, you're learning a bunch about how to set up Kubernetes and how it runs, but you do it alongside practically setting it up. And by the title of the book, it is very, very difficult. Like, it took me a couple of weeks and to go through it and to try and get with it. And I still would not consider myself a Kubernetes expert, but previously to that, I'd done exactly what you described. Like, I'd followed a course or something, and I'd spun up a cluster really quickly and got stuff working, and I thought I understood it, and it wasn't until I did that piece that I was like, actually, I understand this way more than before that. I haven't produced as much in terms of output, but like I've basically just got to the start of having a cluster available, but now I understand what went into doing that. And it's 6 years on now, I think, since I did that, and I'm still learning every day about Kubernetes. So it's definitely a beast. But like, doing that the hard way approach is a really nice thing, and I definitely love to see more books and courses in that realm. Like, learn Kafka the hard way, learn Go the hard way, perhaps. I don't know.
I feel like that's a natural shortcoming when it comes to learning tech for a lot of people. And like, it's almost introduced right when people start learning how to program, because you see so many people who go try 4 different languages instead of just sticking with one language despite it feeling hard or challenging. And I think part of that's that people think, oh, this language isn't for me, or I'm not smart enough, or whatever it is. But in reality, it's just that you need to stick it out and like put more effort in. And it just takes a little bit of time and practice to really learn that deeply enough to understand it well enough to do the more advanced things.
Probably sounds like a really stupid thing to say, but one thing I didn't realize at the start was that like pretty much any language could be used for any of these things. And so, when I was trying to learn and figure out which language I wanted to learn, like right at the start of my career, just coming out of college, I was like, well, I know Java can do this because I did that at school, but like, what about JavaScript? I hear that's used on the web. And it wasn't until like maybe a year or so into my career, I realized, whoa, you can use that on the back end. You can use it for all these things. And it took me a lot longer to realize, actually, all these languages can be used for pretty much anything. And if I stick with one and just become great at it, like, I'll be able to do pretty much anything I want to do. And I suppose, I wonder how many other people kind of don't get that realization until maybe a little bit later on, that sticking with one language probably would have yielded the outcome they wanted if they just stuck with it.
I feel like that's the kind of underlying current for a lot of the discussions we have. Like, even this one about, we're talking about Kafka and event-driven systems. It's like, pretty much anything you can do with an event-driven system, you can do with a monolith for most things that most engineers are going to write. Like, the decision between like a monolith and microservices or a different service-oriented architecture is really one about the non-tech stuff, about like, how do you communicate as an organization? How do you want to set things up? How do you want to scale? And I think that a lot of the rhetoric we have winds up being like, okay, monoliths are completely unscalable and you can't make them work at all. And then you see these like giant companies that have giant monoliths in them, and it's just everything's working fine. Or you see like, there's a whole idea that like that mainframes are kind of this old dead technology. And it's like, no, mainframes power like the entire world. Like, if mainframes disappeared, everything would crumble. Like, you wouldn't be able to buy anything. You wouldn't be able to travel. There's like so many things that would not work without that technology. And we just look at it as like, oh, that's old. That's bad. That's not the good way of doing things. And I think things like monoliths come with that. And or even programming languages, people are like, oh, that's an old language. You don't need to bother with that anymore. And I think that's one of the things that we have to figure out how to fix as an industry. because we are extremely hype driven. And I feel like, Kafka winds up being at the center, or was for a while at the center of a lot of hype. I feel like it still is, of it just like, no, sprinkle a little Kafka on whatever you're doing and it'll fix your problems. And it's just like, no, sprinkle a little bit and you'll have weeds. You'll have lots of problems you need to fix. So yeah, I think we as an industry just need to like really focus on just getting back into that. Like, you can use any of these things to do whatever you want. What matters is how deeply you understand them and how deeply the people around you understand them. And like what programming language you should use is about you, but it's also about who's around you. Like, do you want to work at companies that write that programming language? Like if you want to work on cloud native software and you don't write Go, well, you're probably not going to be able to go work at a company that writes cloud native software because that's all written in Go. Whereas if you want to work on firmware, Go's probably not the best language for you to go work on firmware. There's some companies that are doing it, but it's not the most prevalent thing.
Yeah. I'd like to give a shout out to Incident.io here, because their engineering blog is excellent and they're kind of doing some of this. They're kind of fighting the battle and just like making clear there is a path where you can build a scalable, important company without using microservices. And they wrote this particularly great blog post. I think it was called Split the Workload, Not the Monolith. I think it was called. I can share a link to it. And it's basically about exactly what you described. It's like, we're building an incident management platform. Like, being uptime is incredibly important to us, but we're actually not going to do microservices. We're going to do it as a big monolith and split it down in different ways. It's all written in Go. And I think they received some pushback on Hacker News when it was shared. But if you just read it as take the hype out of it and read it, it's very sensible. And I really like that they're putting content out there that goes against, as you say, like the hype scale a little bit and kind of offers an alternative, because I think they're the best tech blogs. They just offer a slightly different perspective.
It kind of makes me wonder if we'll ever get to a point where people aren't chasing the next programming language. Because like all of us are happy using Go for all sorts of things. But I've already now, and Go's not even that old, but I've had people tell me who are prominent in the Go community that they feel like Go is dying and that some other language is the new thing. And I think they told me that, just for various reasons, but like I've heard it and it's like weird to hear, because I'm like, Go is not that old. And like the amount of things that like PHP and Python are still powering is outright, and people still build stuff in those languages. So I'm like, why would Go just randomly die, all of a sudden? But I think part of that is that like hype thing where depending on the industry you're in, like as an example, if you create courses like I do, or if you do like corporate training, or if you do, like anything along those lines where you're helping companies come up to speed with something new, I feel like you're almost enticed and encouraged to follow that hype train and like help produce more hype about something new, even if it's not better for the people that you're actually trying to help.
Yeah, I think this really does come back to like us as an industry being so extremely hype focused. I mean, it's literally everywhere. Like we're going through the AI hype cycle right now, where everybody's like, AI is gonna change how everything we do works, and it's like, yeah, there'll be change, but it's like it's not gonna revolutionize things in that way. I think like microservices was the same way, and event-driven architecture was the same way, and I mean, in a way, probably agile was the same way back 20 years ago, where it's just kind of like, oh, this will be the one thing that fixes our problems. But I think like at the end of the day, our problem is that we're very bad at teaching people deep things as an industry. Like my own journey trying to just like learn about distributed systems so I can teach other people about distributed systems has been like extremely challenging, because like so much of the literature is very old. So that's an immediate bias that we have right now, because I think a lot of people are like, oh, this book was published in 2015. It's too old. It's too irrelevant. We shouldn't be reading it. And some of the stuff I'm reading is from like 1980. But I think it's also that like it's sometimes tough to actually really dig down and understand like the reasoning behind why you want to learn something or what relevance it really has. And I think the kind of underlying problem is not that like most people are doing this. I think it's fine if most people are chasing the hype cycle. Where I think the problem comes in is when the people that want to create the next foundational technology only understand surface level things. And I think that happens a lot, where it's like, oh yeah, like I want to use like an example I'm dealing with around this right now is like with REST, where I'm like actually trying to like learn REST, and I'm reading Roy Fielding's dissertation, and it's like infuriating, because the things he mentions, I'm like, hey, this is like you could have written this yesterday and it'd be equally applicable to like our entire state of the world. So that feels kind of bad since it was written like a quarter century ago at this point. But also like just how brilliant of a design the system that underlines the web actually is. And then you contrast that with how quickly people want to throw out that design now because they have particular gripes with it, not understanding that, that gripe is actually like a kind of a feature. It's not a bug. It's a feature of the system and it enables all of this other stuff. And I think that those small features, that small bit of nuance, like often gets kind of papered over when people want to just be part of the hype cycle, or just kind of gets thrown out. And so people are like, oh, this thing, we need to get rid of this thing. We need to get rid of this problem. And so the next set of people that are building things are just kind of like, oh, okay, well, that's the problem we have to solve, even though that's could be an unsolvable problem or not a problem that we should be focusing on. And I think like, this, I guess one of the reasons I brought this up is because when I look at Kafka or this kind of event-driven architecture things, I see like what could have been with the web or with REST in general. Like this could have been built as a RESTful system and how powerful that would have been to have these systems within our organizations. But we just don't have that. And the reason we don't have that is because people don't understand what REST is or what these older technologies are. And reading and learning them requires you to go back and read a 160-page long dissertation from 2000, which is not what the majority of people in our industry are going to do. So I think that's like the point of contention that we have at the moment, is that we have to figure out how do we actually teach people these deep things in a way that doesn't, feel like you're reading a textbook.
You don't want to break that book or that dissertation up into like 10 tweets?
People have tried.
You just lose all, like, people know this because they get on Twitter and you lose all sorts of nuance. So like they know that, but at the same time, it is hard to sit down and read, like do deep thinking and think about like something really complex and read about it.
Yeah, I think it's, and part of it too is that I think it's like when generations shift, because like, if you started learning programming in like the early 2010s, there's like a set of technologies that you learned and you're like, okay, these technologies make sense to me. Like, that was the era of Ajax and all of this stuff. And, SOAP and XML and all of this stuff is super bad and gross and we shouldn't have it. But because everybody says all of that stuff, you don't go and learn it. So you don't really know what that thing was. You just know that that's the bad thing. And then you wind up, ironically, reinventing that, which I think is what we've done at this point with like, if you kind of look at what Swagger/Open API has become and what these things are, it's like, oh, this looks remarkably like that thing that we built before. So you've now built the bad thing that you were trying to avoid having. And I think that's like the same thing that's happened with like monoliths and microservices, where it's like people are like, monolith is bad, microservice good, and we should have event architectures. And then you go look at it and you're like, actually, you just rebuilt that same bad thing again. So like you got to go learn the things. And I think that's like, maybe that's the thing I think we should do, is like go learn the stuff that you don't like or you think is bad and understand why it's bad or why it's that way, so you can make informed decisions moving forward. Like I remember I sat down to try and learn GraphQL at some point, and I tried reading a book and it was trying to go over the history of like REST APIs and why REST APIs don't work. And it was just wrong, right? Like the history was just completely inaccurate. And I'm like, how are you at the level of writing a book about this thing if you don't even understand the history of the other things that came before it?
I think some of those, like you said, they are definitely challenging if you don't understand the history. Because even like the GraphQL one makes me think, I went through a very similar experience, and I remember reading a bunch of stuff, and the whole time all I thought was, I've interacted with APIs that are REST APIs that solve all of these problems that like GraphQL is there to solve. And it's like, it's not that it's impossible. It's just that, yes, a lot of APIs implement this poorly, and like you're not wrong there. But I think throwing another technology on top of that and expecting it to magically solve a problem is, like we've said with Kafka and everything, you can't just throw some technology on top of it and be like, voila, this fixes the problem. And I think people saw that with GraphQL, where like, if you have arbitrary queries going to your database, that's not necessarily a good thing. So like you have to find ways to limit things. And then eventually you get back to the point where, you're very close to the REST API system you had before. So I don't know if that's true with Kafka necessarily. Like if you can do the same things, I guess.
With Kafka, like one of the things I remember from the early days of when it was being developed is like the idea was like, oh, you've taken the replication log out of your database and you've exposed it out to the rest of the world, which was like a really interesting and novel idea. And I think, Matt, you kind of alluded to this earlier with like using Kafka as a database. And I feel like for a lot of things that got kind of pushed under, right? It kind of got pushed away. It's like, oh no, we're going to use Kafka instead as this, message broker, which I think it's like an okay-ish, a decent message broker, but I think it's much less interesting of a technology from like a historical perspective as a message broker. And I think it's much more interesting as, what it is, a distributed log and, kind of that part of your database that you've pulled out and then made accessible for everybody to use, and kind of what really that could mean for how we manage data as a whole and what our databases in the future look like. But I feel like that all got lost under the wash of, oh, this is better than RabbitMQ for reasons that I still don't necessarily agree with, but I think that was like a big push of the hype. It's like, oh, instead of using RabbitMQ or instead of using Redis, you can use Kafka and it'll give you these nice properties, and you should just replace RabbitMQ with Kafka. And I think that's to a large degree what people have done with it. But not understanding that history of it, I think we lost an even more interesting thing we could have done with Kafka. We could have built around Kafka and still can. It's not like it's that ship has sailed.
Yeah. And thinking of it as a log enables some really powerful things that may be a benefit of why you do want to consider it. So one of the really nice things about it being an append-only log is you've got a history, right? Like you can go back in time and see what order events happened within your system, and you can replay them too. And you can do that without having to change anything about your infrastructure. So what Kafka enables you to do is for what we call consumers, things that read from Kafka, you can pick a partition within a topic to read from. And usually you'll just say the latest, or maybe you'll say the oldest, but you might pick a specific point in time as well. And when you do that, you can replay messages and you can basically replay history. So say you did have a service that needs to know what happened since the beginning of time. I'll put a big asterisk there and talk about it in a minute. But let's say for the beginning of time, then you could potentially spin up a new service and replay every message that ever happened in your company, and it would get up to date immediately with everything that happened. And when you start thinking like that, that's awesome, right? That's really powerful. And I think that there's probably tons of other message queues that offer you that sort of durability that you could use. But Kafka really brought that to the forefront and made it a feature, which I really, really like. I just want to loop back very quickly on the asterisk I added there. And the reason I added that is Kafka does have retention, like you have, which is something that actually catches people out. When I went back to sort of language you need to learn and things you need to think about before you adopt Kafka, is technically Kafka can retain all of the message on it forever. But that obviously comes with a bunch of cost and storage. So what tends to happen is you keep a very small amount of data retained in Kafka. And I think in Cloudflare, it's somewhere between like 3 and 7 days, up to 2 weeks, depending on the topic. And after that, you kind of wipe history and have to start again. So it means that, say you are having an outage or something like that, and you can't consume events for a period of time, and the amount of unprocessed events is going up, depending on what you set your retention time to be, you've got a finite amount of time to fix your system and be able to work through all those events. So you've always got to make sure that the system reading from Kafka, it can read faster than the rate of events entering Kafka, if that makes sense. So if you've got a message entering Kafka at 1 message a second, and you can read at 1 message a second, well, what happens all of a sudden when you've got a 1,000 message backlog and also messages coming at 1 message a second? You've basically got no levers to pull. You're reading through them very, very slowly. Kafka doesn't support, you can't scale horizontally with Kafka without foresight. You can't just do it on the fly. You have to think about it ahead of time. So you kind of end up in a situation where you can see an incident and you can't necessarily fix it very, very quickly. And so that can be quite scary. And you know that if you don't fix it within 3 hours, 3 days, whatever your retention is, you're actually going to lose all those messages. So, it's a huge benefit of it, but it's also, you can see it as a ticking time bomb in front of you if you can't fix it quickly.
And I think too, that's kind of where perhaps we need more things that come after Kafka to kind of deal with some of these trade-offs. Like I as someone that studies distributed systems, I've studied a lot of CRDTs and like the interesting aspects of like how they work, but also the ability to kind of compact them down small enough to make a feasible, retained forever log of things. But it's going to be tough to retrofit that into something like Kafka. So I think it's like, we shouldn't necessarily just like stay with the technologies we have either. We should try and advance them, but for specific reasons, right? Like Kafka sounds great for the vast majority of things. And if you can solve that problem where you make sure all of your consumers are operating at some multiple of your producers, then you're good. But if that's a thing where maybe you're not going to be able to do that, maybe we need another type of technology that will allow us to have, slower to consumers that have a way of catching up in the future, can do sharding more easily or partitioning more easily than, having to think about that beforehand, as you mentioned.
You mentioned you use an acronym there, CRDT. Do you mind talking us through that?
Yes. So CRDT stands for conflict-free replicated data type. And they are essentially ways of designing your data such that when you want to converge, okay, let me wind back a little bit. So CRDTs exist in the world of eventually consistent systems or eventual conversions, where you might have multiple processes creating data that can't necessarily talk to each other immediately, so that data cannot be converged immediately. So you might have different states of your system at the same time. And what CRDTs do, or what they kind of constrain you to do, is design your data such that no matter how your kind of data comes together when you merge it, you will always be able to merge it without having any conflicts that you need to manually resolve. So a very, very simple example of it is like what we call like a increment only counter, where it's like, oh, I have a counter and I want to, count things across multiple different partitions of my servers. You kind of give each server an ID, then it has a value associated with it, and then all of the servers exchange IDs all of the time, and you always take the maximum ID from every other server, and then you add all that together, and now you have the total value of the counter. And since each server has its own ID and it only increments its own ID, that means that even if at a particular time you don't have the values from the server, you have values from everybody else, once you get the values from that other server, you can just merge it in and you'll have the updated value, right? So there's naturally no conflicts in the system, unlike if you just had like a single counter you're trying to kind of increment across machines, right? So in some ways, it's an alternative to things like Raft and Paxos, which are consensus algorithms that sit at the heart of things like Kubernetes that ensure that you're always kind of making lockstep decisions that won't be rolled back in any way. So make sure like you don't wind up with conflict at all. So it's not really a CRDT, but in a way, it's another way of resolving conflicts. The world of CRDTs is much broader than I think people think it is. It's kind of at a fundamental level, it's just like a constraint on things saying, yeah, no matter how you merge your data together, it must always merge and it must always, resolve. That could be last right wins. So you just say, I don't know, the last thing I have, for whatever the definition of last is, that's the value of the thing, or much more advanced things that you can do. But there's a whole bunch of interesting research around this by people like Martin Kleppman, who wrote a fantastic book called Designing Data-Intensive Applications. And he's done things like make a Google Docs-like editor where he wrote an entire research paper with a colleague, and they saved every single keystroke, every single cursor adjustment, like all of it, the entire history for this document. And it's only about I think 1.25 times the size of what just the plain text is. So you can save all of this historical data in an extremely compact space if you take the time to design everything, right? They obviously have a custom format they're using to store all of that and a whole bunch of other stuff to get it down to that kind of compression ratio. But it kind of yields us to a world where you no longer have to get rid of any of your data, right? So you no longer have to necessarily say oh, well, my Kafka topics are getting too large, so I have to drop some data off eventually. It's well, maybe you can just retain all of this data forever, depending on what the type of data it is. And maybe you do get the benefits of having that long history that you can replay for your company or organization.
That's really interesting. I'll have to take a look into that. Thank you for sharing. I think something you mentioned there, I just want to pick up on, is that book, Designing Data-Intensive Systems. That's, especially if you're interested in event-driven architecture, Kafka and stuff like this, it's a must-read. It's an incredible book. Highly recommend it.
Yeah, Martin Kleppman, that book is absolutely phenomenal. It's a nice O'Reilly book. I think it has a hog on the front of it. Or a swine of some sort.
I'll make sure we get a note.
It is a long read. It's like 400 pages. So just get ready to read a bit. But yeah, if you're interested in this sort of stuff, if you're listening to this episode and you haven't read that book, you should go read it. It's
a book you need to study. I sat at my desk with a highlighter and a notebook and I only read a few pages every day, and it was a slog. It took me over a month to get through it, but I honestly, it's an incredible read. It's not something you'd read in bed, I don't think, unless you're the type of person who can retain incredible amounts of information. But to sit and study, like there's not much better books out there, I don't think.
Yeah, especially if you want to design a system that's going to use something like Kafka, it's really good because it goes over things like, protobuf versus Avro versus other formats that are out there that are going to be integral to you using Kafka and all of the other stuff you have to think about.
So bringing this back to Kafka and Go, since this is a Go podcast, Matt, can you share your experience with Kafka and Go specifically? Has there been anything like stands out as either good, bad, anything like that?
So I think not necessarily good or bad, but I guess just a kind of a brief story of how we've been using it at Cloudflare, which has been interesting. So firstly, I did mention that we've been using protobuf for our schemas. The support for protobuf and gRPC in Go is excellent. It's first class. So that was a good fit and a good choice, and I would make that choice again. So for schema management, protobuf's definitely worth looking at, especially if you are a predominantly Go place. Something else we did is we created a Go library that we call Message Bus. Very creative. And effectively what we do in this is we use, it used to be run by Shopify. It's a Go library called Sorama. Sorama is a Go library that was created by Shopify that basically allows you to do pretty much everything with Kafka. And I actually credit that library with an awful lot of the adoption of Kafka, both at Cloudflare and elsewhere where Go's involved, because it enabled you to basically do everything that the Java libraries were doing. One really hard thing about Kafka, as we talked about, is configuring it can be hard. So one good choice that we made as a company, I think, is we made an opinionated library that kind of set up a very good set of default settings and constraints for how we think you should interact with Kafka at Cloudflare and made it as easy as possible for you to do it. It's got a bunch of power user settings, if you will, where you can override what we deem to be the best settings. But that was a pretty good choice, I think. And we added a bunch of Prometheus metrics within that library as well. So it means that everybody who pulls in our library gets this dashboard for free of how their Kafka service is performing, which was very, very helpful. And again, is another thing I'd recommend doing. It's not Go specific. You could do it in any language, but we were able to do it with Sorama. Slight tangent, but Sorama actually got picked up by IBM. So IBM is now responsible for the maintenance of Sorama, because it turns out that Shopify aren't using it too much anymore. So IBM have taken over stewardship of it. So that's a really cool thing to do. I haven't checked in on the project in a while to see how it's progressing, but it was excellent that they put their hand up to carry on stewardship. And then the final thing that we have been using Go and Kafka for is we built this thing called, we call them connectors. And they're built on there's a framework called Kafka connectors, which effectively allows you to plug some code into your database and plug it into Kafka. And then it just moves the data between the two. So when people are trying to take things out of the database and push it to Kafka, connectors are a pretty common way to do that. We built our own framework that we also call connectors. It's all written in Go. And effectively, with a very small configuration file you write in YAML, we allow you to specify a reader, some transformations to apply, and then a writer. And so what this means is teams can deploy very simple code that reads from a database, apply some transformation to a protobuf format, and writes it to a Kafka topic. They can do it without actually writing any code. They just create some environment variables and deploy it. And same thing, we've got Prometheus metrics. You get a dashboard for free, and we get some alerts around it for free and stuff. So all of these things have really helped with Kafka adoption. And I think if you've got the resource to deploy Kafka at your company, I would really consider having a team like mine, like a platform team that kind of provides tools and services that makes it easy for other teams to do the right thing and to teach them too. I think a huge part of our team's job is just teaching as well, and just making sure people are following the right patterns when using some of these things. And it can help overcome some of these barriers to entry, but obviously it's a large cost investment. One of the reasons Cloudflare picked Go in the first place, and we continue to use it, is it just scales so well. We've had a couple of issues with Kafka consumers not being able to keep up with the amount of messages that are being passed through. But after some small tweaks that you would have to make in any language, we've been very easy to be able to scale a bunch of our services to tens of thousands of messages being read a second without too much heartache. We haven't had to do anything clever. We haven't had to write any sort of crazy code to do so. It's just kind of standard optimizations that a linter would probably help you with most of them, if I'm honest. So Go's been fantastic for that. And even people who join Cloudflare who haven't got experience with Kafka and haven't got experience with Go, we're usually able to get them productive and writing decent code within a week or two, just because of, one, how easy Go is to learn, two, how easy it is to read, which I think is really important and often overlooked with Go. Being able to read it, I can pick up pretty much any Go service and I can follow it through and I can roughly figure out what it's trying to do. I can't promise you the same thing for Java or PHP, where there's lots of auto wiring and magic, and you have to understand the framework a little bit. So that's been really, really powerful and useful for us in terms of adoption too. and generally the performance of the Go app. So like, we are a cloud, so we pay a lot of attention to like resource utilization, right? And containerized Go services, like they are so tiny in comparison to some of the other things that we have to run, and even quite complicated applications that we have running that are processing a lot of data. Their footprint is tiny. So if we were to do this all again, maybe they'd look around at some other languages. And to be completely clear, especially in the context of the conversation we've been having, like there has been more and more adoption of Rust at Cloudflare. More teams are definitely starting to dip the toe in and figure out if that's a good fit for them. And TypeScript too. Like there's been a lot of TypeScript usage, especially in Cloudflare Workers, because it's natively supported and it's fantastic. But Go isn't going anywhere. We see new Go services deployed every day because it just does what we need to do incredibly well. I think one of the huge drawbacks of picking Go and taking this approach that we had, and it's something that we're sort of still reevaluating, is, as you probably kind of inferred from what I've said, we've invested a lot of time in tooling for teams that write Go. If you don't write Go, we haven't got actually a whole bunch to help you right now. We haven't wrote the same libraries in Python. We haven't wrote them in Rust. So we're actually kind of making it harder for teams to blaze a trail and potentially do what's right for them, because using Go is easy for them, which is kind of by design. We kind of want them to stick with Go until maybe it doesn't make sense for them anymore, because we've got all this great tooling that's got, it's got production battled experience. Like it works. But one thing we'd love to support in the future is the same sort of patterns, ideas for other languages. And so we've been exploring some interesting things, like could we put gRPC in front of Kafka and therefore generate bindings for other languages, and therefore we could benefit from the same tooling which would sit just behind our gRPC server. But the teams who interact with Kafka need to know even less about Kafka, because we'll kind of handle the hard configuration for them. And then we can support these other languages too. And the thing that keeps causing me to pause is exactly what Kris was talking about, is if we do this, we're going to remove the need for teams to understand Kafka at all if we do it well. And that sounds like a great thing, and maybe it is in the short term, but I just feel like it will bite us a lot in the long term if we don't. This fundamental piece of infrastructure, if it becomes one team like mine, who knows how everything's configured and connected to it, and another team's kind of passing through it without ever really truly understanding it, I don't know if that's actually optimal in the long term. So we're still trying to battle with that and figure that out. But as of right now, it's the only path I can see to scale all this great tooling we've bought to a way that we can support all these other languages that are starting to appear in the Cloudflare ecosystem.
I feel like you've already mentioned several things that potentially could be challenging in that sense. Like you'd mentioned, you have to be able to consume your messages faster than they're being written. But if you don't really understand much about Kafka and you're just using this gRPC service, you might not really think about that or realize it. And then you combine that with the fact that like even small things like messages being not necessarily in a specific order, depending on how things are set up. But knowing that that's the case, like if somebody's not really expecting that, that might throw them off as well. So like there are a lot, I could see where a lot of those little things, you almost want to force them to understand at least a little bit of it.
Yeah, I was going to say, I think what kind of popped in my head there is like this interesting thing. So as I mentioned, I've been reading like the REST dissertation. And what's fascinating about it is like, obviously there's nothing about like actual programming languages or actual code. In fact, that's kind of the point of it. It's about architecture and behavior. But one of the really interesting things that comes out of, the REST and the web as a whole is that because there's such a focus on like the behavior of like the data and the connectors and the components, which are the things doing the processing, you wind up with this ability to kind of slot things into places and have this kind of dynamic infrastructure that just kind of works across everything. It's actually one of the things that makes Cloudflare be able to be a company at all. The fact that like caching is this first-class citizen of REST, and this thing where it's like, you can have Cloudflare as a cache, you can have a cache, you can have Akamai as a cache, your browser has a cache in it, the servers have caches on them, and they're all doing the exact same thing. And it's kind of this uniform piece of functionality. But the way that happened is because the behavior of the thing was defined, and it says, this is how this component behaves. This is what this component does. And I think that could be a pathway to kind of saying, well, for Kafka, there's all of the stuff that it does, but we're going to shrink its interface. We're going to shrink the behavior of this component down to this specific thing, and then put, a uniform interface in front of it, whether that's gRPC or HTTP or whatever. And then you have to worry less about like the intricacy of Kafka and more about like, are we adhering to whatever this interface is? So that interface might say, well, we have strict ordering for all of our messages. And then you have to figure out how that component does that. And for what Kafka can do, use Kafka. But if you need to do it with something else, then you swap it out with another technology that can meet that same behavioral constraint. And I think like that level of thinking, which I think is kind of where you're starting to get to, Matt, is like one of the things I found to be missing in a lot of companies, where it's like they do focus a little bit too much on the technology. So as important as I said it is to learn the technologies, I think that's also why it's important to learn the underlying concepts and theories of things. So you can say, this is the behavior that we care about. Let's, make something that always embodies that behavior. And if the technology we're using no longer suits our needs for that behavior we need, then we know we got to go find something else to give us the behavior we need, which can also help, you understand when you maybe need to move away from something like Kafka, or maybe when you need to move to something like Kafka.
Yeah, I think you've hit the nail on the head, honestly.
I did have another question about protobufs and like how are protobufs managed at Cloudflare? Because like this is like always a thing about protocol buffers is people are like, these things are amazing until you actually have to like manage like how they get developed and where they're stored and how they get distributed to everybody and all of that stuff.
Yeah. So my number one tip, if you're going to get started with protobuf, is even if you're a small company, centralize them. Put them in one repository, put them in one place, and treat them like code. So we have we're not very good at naming things at Cloudflare. We have a repo called proto-schema. It does what it says on the tin. And so all of our protobufs live there. And anyone can make a pull request, but our team notionally owns protobuf at Cloudflare. So no one gets to merge a protobuf without approvals from our teams. And I think that's important. Like that means we have control and power over stewardship, ownership, break and change detection. So we're the first pass. We'll look through your code and make sure you follow some guidelines and rules. We also have linters in place. We use a mixture of two things now. So there used to be a tool that was from Uber called ProtoTool. I think the people who wrote ProtoTool at Uber left and created Buff, which is like an open source tool around protobuf management effectively. And we use that too. And what it does is every time someone makes a pull request, it checks a bunch of things for us. It checks, have they followed our naming conventions? Have they generated code for all the languages we support? I can't remember if I said break and change detection, but it does break and change detection as well. And so effectively, before you might be making a one-line change to a protobuf, but already we've done like a manual check, we've done naming checks, we've done break and change checks, and we've done some sort of other lints as well. Until you kind of got all those approvals in place and you've merged it, like you can't make a change to protobuf. So that might seem heavy-handed, but from my experience, all of those things are necessary. And I really recommend doing that if you're going to kind of start treating these as schemas. You should treat them like database schemas. That's the way I like to think about it. You wouldn't allow someone to make a migration in your database without having a bunch of checks or approvals. And you should treat this the same way because they're effectively going to be used in a very similar way where people depend on a contract being there. So we essentially manage them like that. And then when you merge them, it generates all the code for you. Depending if it's gRPC or it's going to be used for gRPC or for Kafka. For Kafka, it just generates some Go stuff, just a very, very light Go code to enforce some of those things I discussed around you can only emit one message to one topic and stuff like that. If it's for gRPC, we generate for Python, PHP, Go, I think Rust too now. And then effectively we then tag those as a later version using Semver, and then anyone can pull those in. And we're very, very keen on all changes being forward and backwards compatible, as it's super important. And then one tool we're going to look at in the not so distant future is once those tags are created, it will then go and create pull requests against the services using it to let them know there's a new version released. So just try and encourage them to update there, particularly the servers. Servers are the most important ones to update. Because that's one of the things. You'll hear people say that protobuf is forward and backwards compatible often, which is true, it is. But if the server receiving the message hasn't been updated to understand that there's a newer version of that contract, there could still be some funky behavior, especially if you've added a field that it's never seen before and it doesn't understand. So there's still some ordering going there, and it's not perfect by any means. But for any schema that you're working with, I really do recommend centralizing them and assigning an owner. And I think that will set you up for success.
Okay, I guess that means it's time to move into unpopular opinions, unless anybody has anything else they need to add.
Nope, don't think so.
I actually think you should probably leave.
All right, Matt, I believe you have an unpopular opinion you'd like to share with us.
Yeah, I think this would have been a popular opinion until maybe a year or two ago. But my unpopular opinion today is that I think Twitter, or X, or whatever you want to call it, I'll never stop calling it Twitter, is actually a really great place to hang around, specifically as a Go developer. And maybe you don't have the best view of Elon Musk, or maybe you've heard some horror stories about other subcultures on Twitter. But one thing I will say is the Go community there is excellent, and it's really, really friendly. I've had nothing but like good conversations and good support there. Twitter added support for these things called communities, and I made a Go one. It's got like 3,500 members. Like, it's super friendly. So my unpopular opinion is Twitter is still pretty great, and if you've been avoiding it because you think that it's kind of toxic and falling to pieces, like, as a Go developer, I think it's still quite a nice place to hang out once you've kind of curated your feed a little bit and made sure you're kind of following the right folks.
I feel like you could have made your unpopular opinion even more unpopular by saying X was the better name.
Oh my god.
I'm actually curious how that would do in a poll now. Because I feel like almost everybody just wants to stick with Twitter because nobody wants change of any sort.
There's a few things about changing it to X that just do not work. Like, the concept of a retweet is a good one, and they've changed it to reshare. And obviously, even writing a tweet, apparently now they're called an X. That doesn't make any sense. That doesn't work. So yeah, I'd like to say it's a better name, and I wish that was my unpopular opinion, but it just doesn't work for me, I'm afraid.
Yeah, I think it's less that like you can't change the name of something that has this kind of cultural significance. I think it's that you have to actually change it in a way that creates something with equal cultural significance, and probably isn't trying to just stomp all over the ground that already is there. Like, calling it X is weird because X means so many things already. That it's just kind of like there's not good space there.
I will say the one thing that always confused me was that building a service where people actually call the act of using your service by its name, like tweeting or Googling or, doing something like that, is incredibly challenging. And like the goal of a lot of companies is to essentially get to that point where like they are the standard for that. So like, I'm going to tweet you, I'm going to Google that, whatever it is. And then to rebrand that to something else when you have that seems extremely odd to me. Like, you'd never see Google being like, we're going to change the name of the search engine to something else. Like, they might change the name of the company and do all this other stuff, but they're not going to change the search engine. Like, they still want people to Google things.
Yeah, sometimes people have other reasons for doing things or not the best ideas, but I don't know. Maybe one day X will catch on, but I doubt it. I don't think it will be as ubiquitous as Twitter and tweeting. But I also think that's because of what Twitter meant when it was kind of surging to popularity and how it was different from so many other social media platforms, that it's not inherent in the name. It's just that it had a useful name. So people are like, oh, okay. And quirky features that, subtweeting is a thing, but that's because of the way you could produce posts that were talking about somebody without actually talking about them or like adding them. Right. Or even just adding, right? Like, that's a whole thing that Twitter developed because they started using the @ sign so heavily in usernames that other people now copied. But
I can't really, as far as Matt, your opinion goes, I have very mixed feelings about Twitter. So I'm on the fence there. I find it good for the Go community, like you said, but I definitely can understand that, or I definitely see how other parts of it are exceptionally toxic. So it's very much a use it for limited things.
But it does a good job of trying to stop you from doing that too, right? It's got like the For You tab where it curates stuff that sometimes feels like it's there to try and annoy you a little bit and to bait you. So I'd be interested to hear, like, where's the divide for you? When will Twitter stop being, when will it be too negative that you'll be like, actually, this isn't worth it. This isn't worth the fact that I do get some value out of it. I'm going to start looking elsewhere. Because I think a lot of people felt like they passed that and then came back. I think a lot of people felt that they passed it and really didn't come back. They did find other homes on the internet. So like, where's yours at for that?
I know for me, a lot of it comes down to notifications and things like that. Like, I know by default, the Twitter app gives you all sorts of notifications for like, we think you'd be interested in this tweet and things like that. And I had to shut all of that off because, like you said, it was kind of baity or it was things that I didn't care about. And when I narrowed it down to just the like people I want to follow in the Go community and things like that, it's really helped. I think the minute that stops, like the minute it gets to the point where I can't just get on and in a couple minutes see Go related stuff, I think is when I'll have an issue. Because if I have to go through a bunch of weeds to get to the actual thing I want, I'm basically just going to stop using it. It's not necessarily going to upset me. It's just going to be like, this isn't worth getting on anymore.
yeah, I think for me, it's like, I don't use Twitter as much as I used to, for sure. But I don't know if that's because of the whole change to X and all of that and the trashing of the algorithm, or if it's just because I am less interested in consuming social media as I have been in the past. Now that I'm kind of on this whole new adventure and I'm kind of living in, papers from a quarter century ago or further back. Like I read one from 1986 the other day. I think I personally have shifted so that social media and the kind of the hype cycle that is usually around it is far less interesting to me than it was before.
Yeah, that makes sense.
Okay, Kris, do you have an unpopular opinion you'd like to share?
I have several, as is per usual. I have one that's related to social media, but I don't think it's developed enough yet to be a broadcastable one. So I'll save that one for future. The one that I do have that I've been thinking about for a few weeks now, and maybe I've said it before. I don't think I've said it before though. But I think that our nice little catchphrases that we have, we should just put them all in the dumpster. The most notable one is "Don't reinvent the wheel." I think that is an egregious piece of advice for people. On its surface level, right? Like we constantly reinvent wheels, right? We've been doing that since we invented the early wheels, right? Like wheels on chariots in ancient Rome look nothing like wheels on F1 cars, right? So we've reinvented the wheel over and over and over and over again, and we constantly improved it. But I don't like that phrase specifically because it's so anti-innovation. It's like, oh, well, the things we've already created, that's not where we're going to innovate. It's on the things that don't exist yet. But there's essentially nothing that doesn't exist yet for most purposes. It's like you're not going to invent the next internet or the next telephone or the next television. Like to truly, like, this is a new thing. You're going to improve something that already exists. So I think when people are like, just claim like, don't reinvent the wheel, they're kind of missing out on opportunities to create newer and better things. And also I think like kind of the counter argument to that might be like, okay, well, that's really about focusing on what your main thing is, especially like for a startup or a company. But to that, I would say like most companies that exist in the long term pivot away from whatever their initial main idea was. Like a great example of this is that American Express started off as a package company, right? They were like Federal Express, like FedEx, or they were like UPS. They were shipping things, and then they sprung off into finance, and now they are one of the world's largest finance companies and one of the major credit card companies in the world. So I think it's like to think that you should only focus on like whatever your main thing is right now and not pay attention to the things around you that you might be able to innovate and change on is also bad advice for people. So I think we should kind of dispense with quips like that and stop saying like, don't reinvent the wheel, and actually find more nuanced words for what we're trying to explain to people, whether that's, hey, that might be a good idea, but we don't have the bandwidth to focus on that right now. Or, hey, that sounds like a good idea, but you need to develop it out more before we can actually go and pursue it, or whatever the thing is that you're trying to explain to the person as to why they shouldn't be doing it. I think just the little quips of don't reinvent the wheel, or even the even more popular ones like don't repeat yourself. They mean so much at this point that they mean basically nothing. And they are, I think, actively hostile and holding us back.
I think there's positive ones, Will, right? Like the ones you presented, I think are so. I'm not saying I disagree with the ones you shared because I think you're right. But there's some like one I really like is there's a famous quote from Jeff Bezos, and people asked him like, if you're trying to build it's not often I quote Jeff Bezos, but if you're trying to build a company like the scale of Amazon, like what's your advice? And his response was something along the lines of focus on what makes your beer taste better. And like I really like that quip. I think that makes sense. It's like, if you're building a startup, don't try and build your own auth system to start with, perhaps. Like focus on your key value, focus on your core like concept and what you're trying to innovate on and what you're trying to do. And I think that small quip can actually focus like your attention and time on what you might be working on. And I think it can be a positive thing in that instance. Whereas, I completely agree with sort of the, don't reinvent the wheel. It's like, well, actually, we probably should reevaluate our wheel here because it's not working for us. I can get behind that one specifically.
Yeah, I think there are good quips, but it's difficult to find the good ones out of the bad ones. I think we should. I'm not saying we should get rid of all of the quips. I'm just saying we should reevaluate. Maybe I did say we should get rid of all. I think we should reevaluate all of the quips that we have, because there are like some that just like hit really hard and really good. Like CVS's mission statement is like helping people on their path to better health. And I think like that's such a phenomenal company mission statement, because it's like everybody in the company, it's like, I don't know, is what you're doing helping people on their path to better health? And it's like, oh, yes or no. It's like, it's an easy thing to kind of grok and pull yourself toward too. And so I think those ones that inspire you to think more deeply and have more deep conversations are the quips that we should keep, as opposed to the ones that are more used to shut down conversations, as they often and aggressively are used.
I can definitely see how the don't reinvent the wheel one especially is like it by definition, it is saying don't go do something. And I found this with myself, where if I'm having a conversation with somebody and they're asking for like help about something, you sometimes have to figure out like what's the context of this and what are your goals, because it's far too often somebody will be on the internet and they'll ask a question of like, how do I do this? And people will say, oh, just use a service for that, or don't do that. Like basically they immediately dismiss them of don't reinvent the wheel. A common answer for that is people ask how to build an authentication system. I think I see this on the Golang subreddit like once a month or maybe once every 2 months. And it's almost always unanimously people saying don't do it. But in reality, some people need to understand how that entire process works. Otherwise, we get to a point where nobody knows how it works. And it's like, well, that's not good. So if their goal is to learn and educate themselves and get a better understanding of everything, that's actually a good thing to do. Like there's nothing wrong with that. So I agree with you that it's not good to just dismiss people instantly of like, oh, that exists, don't do it. But I think it's better to like be more aware of what people's goals and intentions are, and like sort of going from that perspective. Because like you said, there are ways to improve things, but if we never are doing it, then that would be a little bit odd.
Yeah. I think like a good counter, maybe not a good counter, but I think that I've been certainly asking myself as I try to build a whole new thing is like, instead of like framing it as like don't reinvent the wheel or like focus on the main thing, I just ask myself like, if not now, then when? Right? Like, there's this thing I got to do. Like authentication is a perfect example. It's like, okay, well, like we have to do some sort of authentication. Should I spend time learning, or should I just pull the thing off the shelf? And so I ask myself, like, if I don't learn this now, when am I going to learn it? Or when am I going to figure out how to build that? And if there's an answer for that, if it's like, oh, in 6 months, that's when I know I'll be able to have the time to actually sit down and learn this well, then okay, there's a when. I don't have to do it now. But if there's not an answer, then that probably tells me that if I don't do it now, then I'm never going to find the time to do it. And that's not great. So I think, yeah, like any quip that inspires you to think more deeply or leads to more questions is a good one. But I think far too many of the ones that we have in tech are just used to shut people down on things, or used to deter people from doing things that they're interested in doing, which I think leads to kind of the thing that we were talking about before of like, people don't know the depth of things because everybody's telling them like, you don't need to know that. Somebody else knows that. Like cryptography is a good example. Like don't roll your own crypto. It's like, don't put your own crypto in production unless you're a cryptographer, but sure, go implement the algorithms, figure out how that works. It's useful knowledge to have.
It is. Don't roll your own crypto.
Yes, do not put your own crypto in production.
Don't roll your own crypto is always such a weird one, because it's like somebody had to know crypto for it to exist and go. Like somebody had to have understood it. So somebody has to understand crypto. So that advice is, definitely not universally true, but people just love to. I get it, because it's one of those things where you want to tell somebody if you don't understand it very well, then like you said, don't push that into production and expect things to go well.
Yeah, but the discouragement of learning is a thing that I have a lot of annoyance with. Because I think people think that there's like, oh, there's a point in time when you go and you learn. Or they think like, oh, you learned in school and now you're in the industry, so now you don't. Or maybe you learn when you're a junior, now you don't need to learn it. It's like, no. This job is learning. Like if you want to build software, your entire, like all of what you're doing is learning. And you'll be continually learning. And everything you build will teach you things. And you'll have to learn new things to build new stuff. Like that's just what it is. So I think the discouragement of learning is like what irks me a lot of the time. And I feel like don't reinvent the wheel, or even like some of the principles we have. I'm just like that.
I think I might replace all my quip usage with if not now, then when. I love that. I think it fits pretty much every situation I can think of. Like I might just start using that all the time.
I was so happy when I was literally just, because what was I doing? I was doing something with, I think, email or designing my website or something, and I was just like, man, I should be doing something. I should go like use Substack or something. And I like asked myself that question, and I was just like, oh no, this is a good this is a good way to refocus myself, because there have been a whole bunch of things where I just said, oh, there is a when. That when is like 4 months from now or a year from now or whatever from now. Yeah, I want more quips like that. I want more of that nice little nuanced bit.
All right. I think that sums it up. Matt, thank you for joining us. Kris, thank you for helping me host. hopefully everybody listening learned something about Kafka, even though we kind of went all over the place on event-driven systems and everything. But I felt like that was kind of inevitable because Kafka itself is hard to like dive into like in too much detail without exploring some of those other topics and seeing how they relate. All right. Thank you guys for joining me.
Thanks for having me. Bye.
That is Go Time for this week. Thanks for hanging with us. Subscribe now. If you haven't already, head to gotime.fm for all the ways. Also, check out Changelog News while you're at it. It's the software industry's best weekly podcast / newsletter to keep you plugged in to developer news worth your attention. Subscribe now at changelog.com/news. Thanks once again to our partners at fly.io, the home of changelog.com. And thank you to Breakmaster Cylinder for producing so many fresh beats for us that we're now releasing full-length albums on Spotify, Apple Music, and the rest. Listen along by searching for Changelog Beats in your music app of choice. You'll find us. That's all for now, but we'll talk to you again next time on Go Time.